Hey guys, this is Fran from coolproject.es producing this video for L'Expert Frigorífics blog. Welcome to this new video in which we are gonna see the thermal load due to the product cooling. Let's go! The product load is the most important load, being between 55% and 75% of the total load. This is the equation to calculate that. The factors we have to take into account on this occasion are the following ones. We have the mass of product daily renovated. It is the daily input in the room. This is the product of the room capacity by the percentage of product daily renovated. In this case, we choose 26%. The result is 6,365 kilograms per day. We have here the specific heat of the product. In this case, for chicken, is around 3,300 joules per kilogram and degree. T sub 0 is the initial product temperature. It is when the product is entering the room, in this case 25 degrees. T sub F is the final product temperature, in this case the room temperature, since the product will be kept at the room for a long period of time. Room temperature is 0 degrees for our project. In the denominator we have the time. This load has to be fought in one day, and multiplying by 24 hours per day and 3,600 seconds per hour, we have the time in seconds. Finally, we have to apply a 50% as packaging load enlargement coefficient, multiplying by 1.15. The final result is 6,990 watts. Well, in addition to this product cooling load, some products like fruits and vegetables generate some heat due to respiration process, and we have to consider this load. In this case of chicken meat, there isn't any respiration load, but we are going to explain how you have to calculate that if there were. We must differentiate between the respiration of the hot product which enters the room daily and the product which is already cooled, because the respiration heat increases with temperature. The respiration heat of a product at 20 degrees may be almost 10 times higher than the same product at 0 degrees. The formula we have to use is this one. In this formula we have the mass product daily renovated, like before, for the product load, in this case 6,365 kilograms. We have this mass of total product in the room, is the room capacity for our project is 24,480 kilograms for the whole room. We have here the specific respiration load of the product at average temperature between inlet temperature and final temperature. It's important to take an average specific respiration load for the mass of product daily renovated. And the difference between the total mass or capacity in the room and the daily renovated product has to be multiplied by the specific respiration load of the product at final temperature, because this product is already cooled in the room. In this diagram we can see the process of respiration for fruits and vegetables is a process in which we have a consumption of oxygen and we produce water, carbon dioxide and heat, and this heat is the one we have to remove from the room. In this case, for our project, we have chicken, and meat doesn't generate heat because of respiration, so respiration load is 0 watts. Okay, in this case there isn't any respiration load, but where can we find this information about the product in case we need it? Well, we have a lot of data in different sources spread throughout the internet, but we have to use some quality information. Some softwares have a database with product information, but the most complete information, in my opinion, can be found in the Azure Refrigeration Handbook. ASHRAE is the American Society of Heating, Refrigeration and Air Conditioning Engineers. We can see here the website for ASHRAE, www.ashrae.org. This is an interesting website in which we can buy a lot of interesting handbooks. One of my favorites is the Refrigeration handbook. We can buy this in Technical Resources, ASHRAE handbook, and we have here different handbooks. You can download here this Refrigeration handbook, totally updated, 2018. Although you maybe can find this guide for free doing some Google searching, I suppose. I have the latest version for 2018. This is the book. I strongly recommend you this book because it's like the Bible of the refrigeration. You can find a lot of useful information here. But for this video we are interested in the third section. Let's go. If we go to the index, we have the third section is food cooling and storage, and the chapter 19, thermal properties of foods, is the one we are interested for this video. If we search this chapter, we can see the index of this chapter and thermal properties of foods. We can go and we have a lot of useful information for many different products. It's very interesting, the table 3. It is on frozen composition data, initial freezing point and specific heats of foods. It's a very large table in which we have a lot of food features and properties. Some interesting data like specific heat, above freezing and below freezing, and latent heat of fusion, which we'll use later to design blast freezers, for example. We have vegetables, here we have fruits, fish, shellfish, beef, pork, poultry products, lamb, cheese, a lot of products we can check here. It's a very useful information. I recommend you strongly to buy this guide because it's very useful. I use this one a lot for my projects. Okay guys, that was all for today. I hope you liked the video, and like always I invite you to comment and ask about it. In the next video we are going to finish the manual calculation for the thermal load with the equipment load and the total load for the room. See you then, bye!